delta sigma delta alpha delta sigma gamma delta then beta h gamma delta sigma delta, and this, if you like, you can write as h alpha beta plus delta h alpha beta. I forgot in the previous one when I had written h mu plus delta x mu, there were other terms, higher order terms of this term contains only one zeta, okay, to the first order. So if you are considering Taylor series, then the next term would be would have zeta raised to the power 2. Okay. So here this plus order zeta square, and here that delta h alpha beta, let me write it here. So this is your zeta gamma delta gamma h alpha beta plus del alpha zeta gamma times h gamma beta plus del beta zeta gamma times h alpha gamma. So actually what is important to see here, the algebraic details are not that important. What is important here is that you have this zeta of gamma. So altogether, these local symmetries, they involve a parameter zeta gamma, which would be zeta 0 and zeta 1, or in the right term, this would be zeta plus zeta minus. Okay. So I mean, because this is a bird seat index, gamma is a bird seat index, so it will take value 0 and 1, or plus and minus. So there will be only two values for this zeta gamma. Okay. So, and this, what we are considering is the so-called bird seat reparameterization invariance, or the diffuse morphism transformation. This does not yet include Weil invariance, okay, that we write separately. So that means the in the conclusion we have two degrees of freedom, gauge degree of freedom from due to this particular symmetry. Okay, and one more symmetry we would have. This would be because of the Weil symmetry. So under the Weil, local conformal symmetry, local conformal symmetry, also called as Weil symmetry. What you have is here delta x mu is 0, but h alpha beta goes to h prime alpha beta, and this is equal to omega. Omega is a function of tau and sigma, capital omega, tau and sigma, times h alpha beta. This capital omega could be taken as also exponential of 2 omega, where omega is a function of tau and sigma, times h alpha beta. This is what we already considered last time, right? Probably I had used the word omega, the symbol omega only for this, and this. So both of these forms, these are called as the finite forms of transformation. But if you expand it as 1 plus 2 omega plus into h alpha beta, then this is your h alpha beta plus delta h alpha beta and plus higher order terms. Then here this delta h alpha beta is 2 omega times h alpha beta. Okay, and therefore delta h alpha beta would be the inverse of this. This would be exponential of minus 2 omega times h alpha beta. This would be 1 minus 2 omega plus times h alpha beta, and therefore dash alpha beta would be minus 2 omega times h alpha beta. So this one is the inverse of the other, but this is how it would appear, because the inverse of this would be e to the power minus 2 omega, and when you expand you get a minus sign here. Okay, so minus 2 omega into h delta alpha beta. So these transformations are called as the infinitesimal forms of transformations. Okay, and one thing more, very interestingly, let me remove all this. So let us have a look at what happens to square root of minus h. This goes to square root of minus h prime. This is determinant of h prime alpha beta. This is equal to determinant of e to the power 2 omega h alpha beta. This is equal to minus determinant of e to the power 2 omega h00 e to the power this h01 h10 h11, and this is I can take it out. So minus e to the power 2 omega e to the power 2 omega into h into determinant h alpha beta, and this would then be e to the power 2 omega into minus determinant of h alpha beta, and this is e to the power this minus h, right? And this is what we have square root of minus h prime, correct? Okay. So now if I consider a product of, let me consider a product of minus square root of minus h alpha beta. So this goes as square root of minus h prime alpha beta, and this is equal to e to the power 2 omega into square root of minus h into e to the power minus 2 omega h alpha beta. Now you see, this is what we have postulated. And this is what has turns out. Okay. So the net thing that you have is square root of minus h into as it should be. So you see, we postulate one and the other thing comes out, and this is how you get its invariance. Now, what is important to notice here, that we are considering the theory in 2 dimensions. So we are very lucky. What happens if you would have this kind of a thing? Then this would not be invariant. So this is invariant only and only for capital D equal to 2. We will not consider its proof, but we need to know for that for string theory, which is 2-dimensional wordsheet, capital D is 2, then this guy is invariant. But if D were not equal to 2, then this would not be invariant. Okay, so this was one more thing. And now after this, I would just recap that thing once again. What we had done was that